get 1 over 36 that way, but you're also supposed to notice that it's 1/6 times 1/6, because this is the probability that the red die shows a 2 times the probability that the green die shows a 5. Now, a lot of times, not always, but a lot of times, you can multiply two probabilities together to find the probability that those events both happen, right? A lot of times, the probability of A and B is equal to the probability of A times the probability of B, but not always. So I think we're going to talk a little bit about under what circumstances you're allowed to multiply them. Yeah, Ethan, yeah. Well, so in general, you're allowed to multiply them if and only if they're independent events. And we'll talk, what?
So like I'm not whether it would, like the probability that it would rain plus the probability that it would not rain, I think you were supposed to add them instead of multiply them.
Yeah, exactly. We added them, and that was the problem we did. We added them. We didn't multiply them. But it's interesting that you should bring that up, because if I were to say, what is the probability that it will rain tomorrow and it will not rain tomorrow? That's 0, right? It's the probability that something will both happen and that it won't happen. But the probability that it will rain tomorrow times the probability that it will not rain tomorrow, that probably isn't 0, right? It's the product of two probabilities, but that number is meaningless because the two probabilities are not what we call independent. Like, one of the events depends on the other one. So we'll talk a little more about that in a second. But for now, let's do another problem where we don't have to worry about independence. Square. Yeah, Katie. Yes, Ethan. So in this situation, you can see that the red die does not depend on the green die, right? If I were to say, what's the probability that yeah, Ria's got it too. If I were to say, what's the probability that the red die shows an odd number and the red die shows a number that is a perfect square, we'd be in trouble because those two events are not independent anymore. The answer would not be, well, I think the answer would still be 1/6, but it'd be by coincidence. It wouldn't, you just shouldn't calculate it that way. You just happen to get the right answer by coincidence. Because 1 is the only odd number that you can come up with that's a perfect square. But anyhow, yeah, so let's talk about what's going on here. There's a 1/2 chance that the red die is showing an odd number, and a 1/3 chance, because 2 over 6, because there's two perfect squares you could be thinking of, that the green die is showing a perfect square. So 1/2 times 1/3 is 1/6. So 1/6 is the answer. Again, you could do this one by straight counting also, right? You could have a denominator of 36, and then you could tally up the number of cases where the red die is showing an odd number and the green die is showing a perfect square. You would get 6 cases. So 6 over 36 is 1/6, which is the answer. A lot of times, though, thinking about things in terms of probabilities is faster than thinking about things in terms of counting, right? If you kind of have to undo the probability, turn it into counting, count a whole bunch of stuff, turn it back into probability, sometimes that takes significantly longer. But a lot of times you can do it both ways. All right.